Welcome to my channel, dear student. Here is the problem, and that is one within the bracket 1 minus 1 by 2 square, 1 minus 1 by 3 square within the bracket, and within the bracket 1 minus 1 by 5 square, and into 1 minus 1 by 7 square or to infinity, and that is equal to pi by 6 by pi square. And this is very important point here is 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square and order to infinity, that is equal to pi square by 6, has been proved in my previous video. Okay, so now I'm using here for this proof, for this question, I want to use here zeta function. Okay, Riemann zeta function in case of prime number. See, this is 2, 3, 5, 7, and you know the zeta function is here. This is summation from n more than equal to 1 to infinity, and that is 1 over n to the power z. This is n to the power z, and this is the Riemann zeta function. Okay, so now for this case is here that is equal to 1 over 1 to the power z plus 1 over this is 2 to the power z plus 1 over 3 to the power z plus order to infinity. Okay, so for this this let us assume as a 1. Okay, now multiply by this equation. This is 2 to the power z then we got here, if we multiply by 2 to the power z with this is 2 to the power z plus 1 over 4 to the power z plus 1 over 6 to the power z plus dot to infinity, that is case number 2, and doing 1 minus 2c, and this is this minus this, take common zeta function of z, take common, this is zeta function of z, and this is here 1 minus 1 over 2 to the power z, and doing here this is 1 by 2 to the power z are cancel out, 1 by 4 to the power z are also cancel out, so we have left only 1 over 1 to the power z plus this 2 to the power z and 2 to the power z are cancel out, doing 1 minus 2 here, so we have left only this is 1 over 3 to the power z plus here 6 to the power z here, so we have left only 1 over 5 to the power z plus dot to infinity. Okay, again this factor if we multiply by 3 to the power z, see here, and this is the equation number 3. This is the equation number 3. So for that multiply by, I want to get here 1 by 3 to the power z, so 1 by 3 multiply by 1 by 3 to the power z to the equation number 3. So then 3 to the power z into 1 minus 1 by 2 to the power z, and the Riemann zeta function, and this is okay, and we got here 1 over 3 to the power z multiplied by 3 to the power z to this equation. Okay, then 1 over 3 to the power z multiplied by 3 to the power z, so you got here 9 to the power z. We multiply 3 to the power z to this equation, this is 1 over 15 to the power z plus dot to infinity, and this is 4, and doing 3 minus 4. Then we got here, take common these two of this here, so we got here 1 minus so 1 minus 3 to the power z into 1 minus 1 over 1 minus 1 over 3 to the power z, 1 minus 1 over 2 to the power z into Riemann Zeta function of z, and we have left only this is here 1 over 1 to the power z, 1 by 3 to the power z are cancelled out, so we have left only 1 by 5 to the power z, like that. This is 4. Okay, now again multiply by the next 5 number is here 5, so this is 2, 3 and 5, so this is multiplied by to the equation number 4, so this is from equation number 3 multiplied by 1 by 3 to the power z. Okay, and this is equation number 1, and this is multiplied by 1 over 2 to the power z, and this is here equation number 4, which multiply by 1 over 5 to the power z. Okay, so see, this is 1 over 5 to the power z into 1 minus 1 over 3 to the power z into 1 minus 1 over 2 to the power z into Riemann Zeta function of z, and this is if you multiply by 5 to the power z to this equation, we got 5 to the power z here, so 5 to the power z, and this is here okay, Twenty-five to the power z plus dot to infinity. So then you got here, this is okay 4, and this is 5, and doing 4 minus 5, then you got here 1 minus 1 over 5 to the power z, 1 minus 1 over 3 to the power z, 1 minus 1 over 2 to the power z, and Riemann Zeta function of z, and that is multiplied by 1 over 5 to the power z to this equation, and doing minus from 4. So 1 by 5 to the power z are cancelled out. We have left only here 1 over 1 to the power z plus dot dot, and this is 6 number equation. And same as if we multiply by, and this is here 6, equation number 6, this is equation number 6 by 1 by this is 5 7 to the power z, then 1 over 7 to the power z into 1 minus 1 over 5 to the power z into 1 minus 1 over 3 to the power z into 1 minus 1 over 2 to the power z into Riemann Zeta function of z, and that is equal to multiply by 7 to the power z to this equation, this, then we get 7 to the power z plus dot dot, and that is 7 number question. So doing 7 minus 6, then you got here 1 minus 1 over 7 to the power z 1 minus 1 over 5 to the power z, 1 minus 1 over 3 to the power z, 1 minus 1 over 2 to the power z, and Riemann Zeta function, and that is we have left only this part, and these are also cancelled out. We have all one of the part here is 1 by 7 to the power z also, so these 1 over 7 to the power z are cancelled out and more, then we have left only a 1 by 1 to the power z and something. So we have got here doing 1 over 1 to the power z plus something. This is, let us assume, is a 8 number equation. So therefore we got here the final equation is dot 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 dot, and this is 1 over 1 minus 1 over z to the 7 to the power z, and 7 to the power z, 1 minus 1 over 5 to the power z, 1 minus 1 over 3 to the power z, 1 minus 1 over 2 to the power z, and Riemann Zeta function. This is equal to, actually got here only one. In each of the case, after the subtraction, we left only the 1 by 1 to the power z in each of the cases, and also some part. And see, we move to the dotted step up to the infinite series. Then we got here on the left hand side only 1 over 1 to the power z. So that is equal to 1. So the zeta function, Riemann zeta function of this case here, so this is equal to, so 1 over, this is a 1 minus, you want to write from this here, 1 minus 1 to the power 1 by 2 to the power z, and 1 minus 1 by 3 to the power z, and 1 minus 1 by 5 to the power z, and 1 minus 1 by 7 to the power z, and dotted to infinity. Okay, so now put here 2. Now required power here is 2, so therefore putting z equal to 2, then we get here, this is 2, and this is equal to, okay, 1 minus 1 by 2 to the power 2, 1 minus 1 by 3 to the power 2, so 1 minus 1 by 5 to the power 2, 1 minus 1 by 7 to the power 2 dot dot to infinity. And you know, for this case, from 1, now from 1 this is here, and 9. Now from 1, from this, okay, put here the Riemann zeta function when z is 2, this is 2 here, this is 2 here, this is 1 over 1 by 1 square, 1 over 2 by 1 over 1 by 2 square, and 3 square, and this is 4 square dot to infinity. You know the value is here pi square by 6. This is pi square by 6, and this is equation number 10. This is 10. Okay, so from from 9 and 10 we can say that this is pi square by 6 equal to, this is 1 over 1 minus 1 over 2 square, 1 minus 1 over 3 square, 1 minus 1 over 5 square, 1 minus 1 over 7 square dot dot to infinity. So that is equal to 1 minus 1 over 2 square, 1 minus 1 over 3 square, 1 minus 1 over 5 square, 1 minus 1 over and 7 square down to infinity, and that is equal to the reciprocal of this figure. So this is 6 by pi square. Okay, this is proved. Okay, this is our square is. Okay, done it. Thank you for watching my video, everybody.